Hi, everyone. My name is Yochay, and I'm going to speak with you about AI as a service with Converge and Dell AI ready infrastructure. So a little background. I'm Yochay, CEO of Converge. I'm a developer or a data scientist that turned into a CEO. Founded Converge together with Leah, co-founder and CTO, and Converge is a machine learning platform. So we help data scientists to build and deploy machine learning models to production. One of the key things about Converge is that we connect scientists, engineers, and infrastructure engineers together in a single platform. The story of Converge actually started a few years ago. We were doing data science as a service, and we were basically providing professional services around machine learning, mostly around NLP and speech recognition. And as we built models, we saw that we need a platform to help us organize our experiments research. We also noticed that we spend a lot of our time on stuff that don't really relate to data science, like DevOps and IT. So we built Converge, and Converge was an internal product that was very helpful for us. We saw it can help a lot of other companies as well. So we decided to take it out to production and build a company out of it. Over the past few years, we've been shipping Converge to many different customers that are using the platform for autonomous driving, computer vision, NLP analytics, forecasting, and basically any kind of use case you can think of. The product itself in terms of architecture, so platform built on top of Kubernetes. Converge is a cloud native platform. You can use any type of container that you want in the product. It's very open, very flexible, and provides a lot of speed and performance improvements for developers. In terms of what we offer in the product, so basically everything data scientists and organization need to build models, whether it's training, automation, infrastructure, scheduling, orchestration, any kind of use case in the machine learning lifecycle. One of the unique capabilities of Converge is the fact that it can actually support hybrid cloud and multi-cloud deployments, and also any type of hardware. So today we're going to speak a little bit about hybrid and multi-cloud, specifically in machine learning, and how it's becoming more and more popular. And we'll also show you a quick demo of how things are working. All right, so we started Converge a few years ago as we saw that most of the day of the data scientist is spent on non-data science work. So you have, as a data scientist today, you need to configure hardware, you need to configure the platforms, you need to be a Kubernetes expert, you need to be familiar with resource management, scheduling. If you have a hybrid cloud stack, let's say you have your own private on-prem GPU cluster and also cloud clusters, then this is becoming even more complex. Of course, data scientists need also to manage their models and data sets and versioning of models and data. You also need to take care of deployment and production monitoring, and maybe also some configuring some homegrown tools, open source tools or anything. And then a lot of the time is spent on the non-data science work, and very little is left for the actual machine learning, actual model development and insights, and also putting more models to production. Now, this is, besides the fact that this is really frustrating for the data scientists, for us, this is also impacting the business. So in Converge, we see 50% OpEx waste. We see clusters, expensive clusters that are not being utilized. We see slower time to market when you want to build models. This is obviously, it has to be fast. Many of the time it's about the competitive advantage of the company. So a slower time to market is indeed a big problem here. And eventually we also see revenue lost. Now, why is this happening? Because when you look at AI development today, it's broken. And it's broken because machine learning development is still pretty new. There are actually two main flows today with data science. On the left side, you have the MLOps, DevOps maybe side of things, like how do you configure the development stack? How do you do resource management? Maybe also in complex environments of like hybrid or multi-cloud. How do you connect machine learning, which is pretty new, to the existing IT stack, whether it's Git, whether it's Jira, or all the maybe monitoring stack. And also eventually when you have more models to production, how do you monitor them at scale? And on the right side, you have the actual data science workflow, which is data selection, data prep, model research, experiments, running more experiments, more training, validation, tuning, and eventually also model deployment. Now, those two flows are pretty much isolated. Many of the time, it's two different teams, different groups. And as a result, there is some sort of like a technical depth in the organization for AI that results in the fact that many of the models don't make it to production. At Converge, we provide an AIOS, we like to call. So basically everything data scientists need to build and deploy models. The platform is extremely open, but also very fast. So provides like superpowers for data scientists. You can actually run workloads, any type of AI workload, anywhere in a single click. So you can actually spin up model training on GPUs, data pre-processing on CPUs, on-prem, cloud, everything is supported. We also have great integration to third-party tools, and the product itself is developer first, code first. So APIs, SDKs, everything needed to build integrations on top of Converge. This is an example of an end-to-end AI pipeline built with Converge. So you actually can load the data, you can run Spark pre-processing on a CPU cluster on-prem. Then you can also run model training. Some of the training could run on GPUs, some of it can run on CPUs, and eventually the serving can actually run in the cloud. So in a single pipeline in Converge, you can orchestrate workloads across on-prem or cloud. This is extremely powerful because you can really have the right tool for the job that you're running. So obviously it saves a lot of money. You can also have some cloud bursting capability and easier ability to scale. All right, some of the benefits of like capabilities of Converge is that it operates very well in complex infrastructure setups. What does it mean? It means that basically you can have Converge application deployed on-prem, and then you can actually connect multiple clusters into the same Converge deployment. So from this user interface of Converge, whether it's the CLI or the SDK, you can run workloads on any of those clusters. And we have integration with cloud clusters, of course, and with on-prem Kubernetes, OpenShift, Tanzu clusters are supported as well. Basically, any resource that you have can be connected and attached to Converge. This helps you to create like a one unified environment for all of your AI compute. And we actually have some very nice examples from customers, real production customers that are using Converge to manage this type of AI architecture. So this is an example of a customer that uses the Converge meta scheduler. This is how we call it. Basically, think of it sort of like Kubernetes for Kubernetes, like Kubernetes of Kubernetes. Basically, from a single Converge application, the customer connected their on-prem GPU clusters. They have two DGX1s connected to Converge. Then they also connected their AWS account and also their GCP account. And now data scientists can actually run workloads anywhere they want. They don't need to specify specific, I don't know, roles or permissions, or move the data between the different, worry about networking, about access. Converge automates everything, of course, with high level of security for the enterprise, and data scientists can now spin up those resources. Another example is a customer that that has a bit more complex environment. So they have a lot of CPU workers, single nodes, huge nodes, and also they have a GPU cluster, and they have also split to training clusters and production clusters, and also Hadoop, Spark, on-prem clusters, and AWS. With Converge, data scientists now have a single unified environment with where they can access remote AI infrastructure. Now, we have a lot of different use cases like that, and one of the motivation to have this kind of setup of both on-prem and cloud is because of cost, of course. And we surveyed our customers why are they building this type of architecture. So cost, security, sometimes you will have sensitive data that cannot leave the on-prem environment. Cost, of course, because leveraging the on-prem compute will be cheaper than using cloud at some point. And but on-prem customer will still want to have cloud because of scale, because of flexibility, speed. So this type of use case is growing pretty fast. So in the past few years, we see this architecture growing, and more customers are using this exact architecture. They are looking to have this type of flexibility, and with Converge, you can achieve that. Now, we also work very closely with Dell and provide a integration to Dell as a service to Apex. And for an example, this is like a reference architecture that we have with Dell. So you have the Converge AI OS. You then have your on-prem workstation. You can also connect to Dell, and you can also connect to the cloud. So from a single UI, a single interface, data scientists can do all the different workloads, training, data prep, deploying models on Dell or on the lab workstation or in the cloud. It is great because with Dell, we provide the speed of best integration, cost optimization. So and also still have the ability to scale to the cloud if you have, I don't know, your production monitoring stack already installed there. So this flexibility, think of it, you can actually design your own AI cloud. And that's a big motivation for a lot of data scientists and data engineers, and also IT. Now, one of the challenges that you have with hybrid cloud is the data gravity. So even though machine learning workloads are stateless, and that's perfect for the hybrid cloud world, you still, most of the workloads are consuming or using a lot of data, and data that could be terabytes of data for a single model training, or a data pre-processing step. And with Converge and with Dell, with this joint work together, we designed a solution that allows basically solves the data gravity problem. So we call it data caching, and it's actually pretty simple. So Converge supports data lake with object store that is connected to the Converge control plane. And then think of it, you have the Dell data center here, and you also have cloud instances here. Then any workload that is running, that you run, will actually need to fetch the data from the object store to the instance it's running on, even in the cloud. S3 to cloud to EC2 is it can take a while if it's terabytes of data. So what we designed is this warm data notion. So you have like an NFS attached to the cloud instance or to the data center. And then the data, we in Converge in the product, we identify data that is frequently used and that is popular. So we automatically cache it on the remote instance, whether it's cloud or on-prem. And then anytime a data scientist is running a workload that is using a data set that was defined as warm or popular, then the data scientist won't need to download manually the data. The data will just stay there. It will sit and wait for the next job. If the data scientist is not using the data for a while, then Converge will automatically clear the cache. So this is perfect for the AI world because first, data scientists don't need to manually move data between the different instances. Converge does that automatically. We also optimize the data download from the remote object store. So it's being done pretty fast, and you can actually get really fast results. All right, let's do a demo. All right, so this is the Converge platform. As you can see, this interface is web-based. We also have a Converge CLI. We have a Python SDK. Very easy to integrate to the product itself. You can log into Converge and start deploy it on your on-prem hardware and or in your private cloud, and you can just start your machine learning journey. We have a lot of pre-built examples. You can also, of course, import your own project, and whether it's computer vision examples, A/B testing, canary rollout, using Dash, a lot of different use cases are available. Now, with the dashboard, you can see what workloads are running now on what compute. So you can see I have Dell and I also have my default compute. So I have 20 CPUs available for my workload. This is the history of my jobs. I ran CNN, XGBoost, and I have a batch model deployed. Here I can also set priorities, check the queue. And this is a single dashboard for all the resources, on-prem, cloud, any resources that are attached to the platform. Now, we also Converge is based on containers. So any container can be used in Converge. We basically help you to orchestrate the AI workload using any container. You don't need to add any kind of dependency to your Docker image or to your code. Everything can run out of the box. Now, as you can see, we also have a pre-built list of many different containers optimized for specific hardware, all open source and brought by integrations. And I want to also show you the compute, and the compute is really where most of the presentation we talked about. You can attach different resources instantly from Converge, on-prem resources, cloud, Dell is already connected, GCP, Azure, all of those resources are available. As you can see, this is my Dell resource. Converge is also continuously running health checks on the remote cluster to make sure that it's alive and healthy. And if something bad is happening to the cluster, like it doesn't pass the health checks, then Converge will notify the admin. Now, just to show you a quick example of the pipeline in Converge. So this is a training pipeline that I built beforehand. This is a drag and drop interface and can also be represented by code, by YAML. I can add steps to the pipeline very easily. And the cool thing about this is that each step can actually run on a different container with a different compute. So pre-processing can run on my on-prem Dell CPU cluster. Then XGBoost can run on my Dell CPU embeddings and CNN can run on Dell GPUs, or maybe cloud, or maybe accelerators, anything I want. Then the register of the model is being deployed, basically deploying the model to an AWS service. And once I click run, Converge will orchestrate all those different workloads one by one or in parallel, like those three. And also everything is going to be reproducible. Everything is going to be tracked, fully tracked. So you can build dashboards, show the performance of your models, of your data steps, anything you want very easily. So there are a lot of capabilities in Converge in addition to this pipeline, but you are more than welcome to join the community or visit our website and contact us if you have any questions. I'll be happy to answer now some live questions. Thank you.